future hand in hand in this tech-driven wonderland.
Okay, hello everyone, and welcome to episode 33 of Near Office Hours. Today we have Felix from XTrace. Felix, do you want to say a couple of words about yourself and what XTrace is doing?
Yeah, so hi everyone, I'm Felix. Thanks for having me here. I was previously in the Stanford's Computation Mathematical Engineering program, and now XTrace is creating encrypted vector database and encrypted memory for AI agents. What that means is that we can store encrypted data in the vector database and then allow user to submit encrypted query into the system and retrieve the most relevant data. And then this is on top of just encrypted in rest and encrypted in transit, we allow data encrypted in use. So your data will never be leaked before for any malicious attacks.
Yeah. So before we started the recording, I was reading up a little bit on XTrace, right? So it uses homomorphic encryption, right? That's the technology behind all of it.
Yeah, it's like a combination of embedding models plus partially homomorphic encryption. Yeah. So.
Yeah, we talked to a couple of people here on the previous episodes who work on homomorphic encryption, and I think one interesting question is how fast it is now, right? Because homomorphic encryption has been around for a while,
yes,
but for most interesting use cases, it's been prohibitively slow. So I'm curious if there are some breakthroughs that enable it, or if it was always possible to do it for embeddings, but nobody has applied it yet. So what is the secret sauce here?
Yeah, the secret sauce is kind of like we're kind of thinking about like AI and cryptography. We're kind of the chain that connects it. And then if you're just using regular embeddings that is working with floating points and then combining it with fully homomorphic encryption, we did a benchmark. So each data chunk that you need to calculate will be like 30 seconds per data chunk, which is not practical for vector retrieval performance. So the secret sauce we're using, which accelerates the speed to 0.092 millisecond, is by simplifying the problem space to working with binary embeddings. So we train embedding models in AI using Matryoshka representation learning plus like the bit quantization to make sure that even though we can do like a distance preserving transformation from floating points to binary embeddings in a hypercube. And then we do all the operations on the encryption space with like just bits embeddings. And then by doing so, there are a lot of like ways to accelerate the speed and then like improving the performance. So that's kind of how by focusing on a smaller problem, first like getting this is a big problem, we use AI to map it into a smaller problem, and then we in the cryptography space we accelerate it to get to like the 1000x performance boost. Yeah.
Mm-hmm. So usually, and my knowledge could be a little bit obsolete here, right? But usually my understanding is that the embedding model is also a transformer, right? Where they like I know, like back in the day, I don't know if people still do that or this is still the primary way, right? But back in the day, they would just get a transformer and get the last output of the last layer before it goes to the softmax, and that would be the embedding, right? But obviously, that's a binary embedding, right? So to get the binary embedding, do you completely retrain the transformer, or do you train just like the mapping from the last layer to binary, or what is the approach to get there?
On the last layer, and then we're not arguing that we'll get the same performance as like the floating point inference. What we're trying to say right now is that this will be distance preserving, because in a vector search, what we're only caring about is like the relative distance between your query vector and then the relative the distance to the embedded vector. So that's why we kind of can do something more like a local sensitive hashing by like mapping the space from like the floating point space to like the hypercube space of 0 and 1s.
I see. So it's sort of like quantization, or is it?
It can treat it as like kind of like a quantization, to get it to like this, And then we actually created a mathematical proof stating like doing this transformation, we still preserve the relative distance in our white paper.
I see. Okay. So now, So I guess the core component now I understand, right? So you have a vector database, right, that maps an embedding. So I compute embedding locally on my machine, right? Then I use homomorphic encryption to get an encrypted embedding.
Yes.
Right, and then that is what's going to the XTrace, right? So this way, in transit, it is already not something people can see, right? So then there is a vector database on your side, right? And then whenever I want something to retrieve, I again compute the embedding. It gets homomorphic encrypted, goes to their magic happens, right? And so because of homomorphic encryption, you can compute the distance. So now let's talk about use cases, right? So what would be, because obviously the alternative, right, is just to have vector database locally, right? I just spin up an instance on AWS with like a large hard drive and run a Postgres with whatever PG vector, right, and store embeddings there, right? So why would they, like as a user, right, or like what is the primary use case? Why would people use XTrace as opposed to local?
It's kind of like the phenomenon before Dropbox and after Dropbox, right? Because if you're doing everything locally, all of your data is not portable, shareable at all. And then so if you have just like a simple use case of just yourself, you cannot share the data from devices to devices if you're just hosting everything locally. And I think your approach is what like model context protocol, which is what Anthropic is doing. But for us, for a system, we can kind of allow this protocol to be exit outside in like the cloud level, and all of the device connected on it can like have access to it. And on top of it, we can allow like multi-agent collaboration, or it's like multi-human collaboration. Like Alex and Felix, we can have like a collaborative knowledge base that both of us have access to, and only us have access to. And then this can be on the cloud level instead of just letting everything be on the local level that might be obsolete. Yeah.
I see. And so it's if we have a shared knowledge base, we would be able to decrypt everything in there, right? So it's not like we're hiding anything from each other. I see, but nobody else will.
Yes.
Yeah. I guess yeah. So like in this case, I can still spin up my own instance, but then I need to be a tech-savvy person. It would be sort of like hosting my own email server as opposed to using Gmail, right? And XTrace would be like Gmail, right? So like where.
And also some cool use cases, like we're also talking with some like those data labeling companies, like say Public AI. We can first like allow agent to do semantic search on all the cipher data, and then they can first identify which chunks are relevant to them to buy, and then they can just buy the specific chunks instead of buying all the database decrypted and then like start working on top of it. Yeah. And then we're also working, so that's kind of like also another use case. And on top of that, what we're most excited about is like this encrypted memory base for AI agents. So that if you're talking about agents running in TE, now we can make this agent's memory transferable and then inheritable to other agents. So now like one cool project we're thinking of doing is saying like we can create like a sandbox texting environment for like AI agents. Like previously there's like this game about like convincing like the AI agent to give you like prompt hacking to give you release all the fun, right? But that's just like a one-time thing. But if you're using our system, we actually create state in this agent. So the agent will see this attack and then know that this attack exists and then learn from it. So this can be extrapolated to a lot of like AI guardrail or like Web 2 security systems. So that like agent developers, they can say, okay, my guardrail is I don't want to talk about the competitor's name for my AI agent. I specify this guardrail, and then I put it in like XTrace sandbox texting system, allow people to attack, jailbreak it or something to talk about their competitors. And then once something triggered, then we can recording your memory. You get like the whole memory base that is transferable before we. Oh, sorry, I think disconnected. So after we launch it, then we can have like the user seeing it. Yeah, the agent will inherit all the past attacks, and in the future, if it sees it can prevent it. Yeah.
Yeah, it's interesting. So let's begin with the first use case you mentioned, right? With the public AI. That's right. So that's interesting. So you have a large set. So in this case, the vector database contains a mapping from embeddings to like to some annotated to some data points on which you can train, right? And so in the past, you would go to the provider and say, "Hey guys, I want to buy the whole data set."
Yes.
In this case, you can filter it and pay only part of it. So in the pitch deck that And look, there's another interesting use case that was mentioned where you guys look at the idea of having like a global knowledge base of all the agents or something like this. Is it?
Yeah.
Is my understanding like along the lines of what's happening?
Yes. So what we're saying is that if like I think the new form of data, because kind of like in the previous newer IPS meeting, they're saying like we're out of like all this public data, right? And I think the new form of data will be like, because now they're doing like multi-core reasoning for like all the inference optimization. Like a new form of data is they are generated by AI agents, and then this will be recorded in the memory system. And then now we're arguing that now this whole experience of AI agent, for instance, you have a junior developer, you have like a senior developer agent that have already solved a lot of bugs. And then when a new user launches a junior developer agent that have no experience, they can directly have access to all the previous knowledge of the senior agents, and then use it as like a way to inherit experience. And then instead of inherit from one, this is really scalable. You can inherit from 10,000, and use all of that as a context data for you to perform certain tasks. And then our encryption allow all of this agent to maintain data ownership because everything's encrypted, and only the authorized party will have access to what they need. Yeah.
Yep. So I think a couple of things that are interesting here. One is that presumably for this use case, with like junior developers inheriting knowledge, the embedding would need to be somewhat different, right? Because it's not just the embedding. That makes sense what I'm saying, right? Because the embedding would need to capture the go ahead.
Yeah, so we're not just storing like the binary embedding is used for search, and then we still have the AES encryption of like the actual text or like the actual embedding they want to work with. Yeah, so after they identify the data they want, they can get like the embedding that matches them, or actually get the raw text based on like the pre-chunked data. Yeah.
Yep. Yeah, and then like effectively. So again, interesting thing to consider here is what would be the competitor of this approach, right? So competing approach would be something that stores all the data. So if agents are running in the TEs, then you can also, like I can imagine a system where agents are running in the TEs and the vector stores in TE, right? So if the vector stores in TE, you can have similar guarantees to homomorphic encryption. Homomorphic encryption is strictly better because you don't have to trust Intel, right? And not only you don't need to trust Intel, you don't need to trust, like I guess with the TDX, the biggest concern people have is not that Intel will be malicious, right? And then and will steal their embeddings. This is unlikely, right? But that that Intel messed it up, and there's some sort of attack where you can measure like a cache latency, and that will allow malicious actors to extract data, right? So homomorphic encryption is stronger. But one interesting problem here, and I don't know if this is something XTrace is trying to address or if it's considered to be unlikely, is that like I can launch a junior developer, right? And I can go like collect some observations that are relevant to me, get them, presumably pay for them, right? Because if there's ownership, then presumably there's some payment involved, right? But now I have the data, right? So now I have an incentive to share it as my own, right? Because it will be the same embedding. Right, and so people will be able to buy it from me. So I don't know if this is something that you guys think about, like how to handle the idea that once I get the data,
like reselling. I think it's kind of turns to a lot of like also like say Web2 systems. Say we're doing online bookstore. How do we prevent people from like reselling the book of the author once I purchase like the online bookstore? And I think my argument is that psychologically people will want to more work with like the authorized, and then especially in the RAG framework, you only get a chunk of data. I think getting a few chunks of data won't be really that useful comparing to having like the whole data set that is semantic searchable by AI agents. So I think it's really hard to monetize just like a few chunks. And then and then if you want to buy the whole vector database, I don't think you have the reputation authority to like resell it. If people want to buy like Alex's agents like vector database, even though I claim I get all of your vector data, I don't think I'll be that appealing when trying to resell it.
Yeah, because the model I had in my mind is that it's like a global right where everybody can contribute, right? So if everybody can contribute, then the fact that the senior developer published more data and I published less data will be less relevant from the person who's fetching data, right? Because when I fetch data, it's less important. Yeah, I guess details would matter here, like implementation details. Yeah, like I guess some sort of reputation system.
And then it's also kind of different between like, say, the previous idea about like, oh, we all collect data to train a model. By using like this kind of vector data search, only the most relevant data will be retrieved. So it kind of also against all those like just like dumping, because if you incentivize people to give you data and you don't care about quality, people just dump all the weird like useless data into the system. Yeah, so I think a quality control kind of also we can say like how perplexity works. You can say because of this citation of certain data, so we make this inference. So the attribution will be pretty clear. In comparison to say we all work together to train this model and we have an output, there's no way to attribute it back to whose data caused this inference. Yeah.
Yeah. Yeah. So in terms of you didn't explicitly mention it, but I'm pretty sure it's assumed, right? And I just brought it up a second ago that because there's data ownership, there must be payments, right? So presumably, if I store some data, like if I offer some data on this, like I assume it's some sort of a marketplace, right? So how do you imagine the system working? Is there like is it some sort of payment channels or?
Yeah. So there's a lot of agent payment system out there with like we're also talking with like Nevermind and like those kind of agent payment system company. But at first, to bootstrap our idea, we're trying to focusing more on like collaborative settings where different companies are trying to work together and then trying to have a collective knowledge base. And then based on that, we can extrapolate, because the only difference behind the tag is authorization token versus like a payment token to unlock the system.
Yeah. And I guess we mentioned multiple use cases today, right? So there's one where I as a user use it myself, right? In this case, there's no global RAG, right? Or I guess it could be if there's multiple users collaborating, but even that is like right. But I think like thinking, trying to imagine how it unfolds, right? I can imagine that personal would be way more like way more people will use personal, RAG than like sharing with one or two people. I don't know. I need to think of use cases.
Like for instance, like inside the corporation, we can have different teams who have a collaborative knowledge base. Like for instance, you will never want like the engineering team to have access to the HR data about someone's assistant. So maybe we can have like different RAG with multi-tenancy control, different access control, and different like collaborative knowledge base, even in a corporate setting or like And I think security and this kind of access control will be vital for like real adoptions.
Yeah. But I'm curious. So I guess there's a difference, right, between going after like individuals, right? So like I can imagine like some sort of agent application running on my phone, like learning about me, like learning about my preferences, my calendar, right, and all of that goes into this Dropbox. Of RAG, right? And then like I'm on my phone, I'm on my laptop, I'm on my iPad, and it's all shared, right? So I assume like that requires having the actual application. So I don't know if you imagine that you would be building them, or if you're working with partners, or if this is still more the idea level.
For mostly currently more like trying to B2B, so we can create like this agent tool for like developers of agent to have this like privacy preserving feature. And then like what we're trying to gather is like all this encrypted data from all these individuals. So not only about like on different iPad, different phones, we can also work with different AI vendors. So if I upload my personal data with Felix, in the future, like maybe other AI agents can I can have access control. I can choose which AI vendor I want to share my data. So I upload once and then I can work with all these services, and then choosing the specifics that they want. So for instance, if Amazon is having their own AI agent, I can basically open like my shopping experience data to them only, and I don't have to give out the other ones.
Yeah, that makes sense. And so are you like deeply integrating into existing agent frameworks, or like how do you approach the go-to-market?
So currently, I was also working with like Cameron, and say we'll submit like a pull request in like near AI Hub to create like where this encrypted vector support for like different teams who are caring more about like users' data ownership, and then also like the privacy and security of the data. So, and then also different protocols allowing them to like use the same protocol of XTrace to like encrypt their own data and then put it on the system. And then now we kind of want to be like this bridge of allowing like different AI vendors to like maybe query different AI vendors partners' data, and then having like user who has a control over what data to give. Yeah.
Yeah, and I think you mentioned it, but so in this case, I as an agent developer, do I choose the model that computes embeddings, or is it something that is pre-configured?
You can choose the model to do the embedding, and then we'll transform your model from like any floating point to like the binary embedding. Yeah, so we're compatible with any embeddings. Yeah.
Yeah, that makes sense. Yeah, and like how far along is it in terms of like is it fully ready to be used, or like what's the roadmap?
So we already developed the SDK, but we haven't really created the infra code yet. So how it works right now is that the developers, you have to take some work to like launch the instance and then use our SDK to encrypt the data. And then we support like API to retrieve the data by calling out the prompt. Give out the prompt, we encrypt it, and then get it. Yeah. So the workflow is done, but we don't have the infra as code yet built out. Yeah.
Yeah. And what is the like? I guess eventually, like at some point during this process, XTrace needs to get its share, right? So what is the business model? How, do you like if I deploy myself the XTrace instance, right? Then
yeah, I think it's kind of like how business work. Like we'll create like I think where we actually make sense is when we create all this hosted service for you, so you don't have to do all the hard work, and then we can have like the biggest mode, even though it's encrypted data, mode will have like all this encrypted data from different users. So like if an AI vendor wish to enter a protocol directly, they'll have all this access encrypted data, and then they can have ask query for like user to get all like work with different like users and then directly have access to it if the user agrees. Yeah, and I think that's where like our business model is. Like first kind of like more like a traditional hosting service, like how like they work for like SaaS business. We help you do all the infrastructure. You just have to give us the data encrypted and we'll do everything for you. And then on top of that, we can create this protocol level of like agent to data and the agent to agent communication.
Yeah. I guess it's also interesting how. So you mentioned. Let's begin with a simple use case for the question I have in mind, and then develop it. Right. So let's say you and I want to have a shared vector database, right? So how does the key? Do we both have the full key, like the same key, or how do we establish it?
Yeah, so both of us will first agree on like a key first. So it's kind of like all those. It's kind of pretty already mature, like how cryptography, like in blockchain, how people like can have we co-own this system. So we create like this public key, secret key pair that both of us have, like using some threshold distributed key generation or threshold encryption technique. And then we can co-control the vector database and making sure only both of us will have access to it. And then you can do, and it depends on design. You can design it such as we need both of us to agree to decrypt the data, or both of us can decrypt the data individually. Yeah.
Individually, yeah. Right, but how does it work with the more complex case, right? So let's say public AI has this vector database with like a massive data set of I don't know, annotated alignment prompts, right? So right, and then I go and I query. So effectively, initially, like does public AI in this situation have to be involved in decrypting data for me when I
using asymmetric encryption? So the public key of public AI will be outputted. So to do like the search, the user just have to encrypt their prompt with the public key of like public AI, and then go through and then we can do the calculation for vector database, and then we'll let public AI tells us like which data is relevant based on the user's query, and then they can do like a data swap from the public AI and the user.
So the actual data fetching you do need both parties to be online.
Yes.
And yeah, okay. So it cannot be facilitated by the system. I see. So it's just the search.
Mhm.
Yeah, that makes sense. So in this case, as a provider, if I have to be online anyway and serve data, why would I not also just run a vector database? Like again, Postgres with the PG vector. That does make sense?
Yeah, so I think it's kind of based on like the scale. Like if it's 1-to-1, I think it makes sense to just do that. But I think what we're allowing is like one user, they can submit a prompt and then go to all 10, 20 vector database, all like in a uniform protocol level. So they don't have to go through one by one. And then we can, so if we have scale, then it makes more sense to just like become a unified API layer. So you just do one API prompt, encrypted query, and then you can go search through all the different like providers.
Yeah, that makes sense. Yeah, so that sort of goes back to the idea of the global knowledge base. Yeah. It sort of fits well with this other idea that we've been promoting, where called proof of response, where because in this case, I can imagine long term, like I don't think short term that will be a problem at all, but long term I can imagine a problem where like I came there, provided some data set, and I was like a small company, like we fundraised 100K, annotated some data, provided it, the company died, we shut down our servers, but the embeddings are still in the embedding database, right? And so the user comes there, does the search and says, oh, this is the data I want, try to fetch it, but there's no
data coming back.
The provider is not coming back, right? And so, like naturally, short term, that's not going to be a problem, right? Because short term, I guess it will be like 10 providers, right? And all of them. If one of them is offline, you can act on it, right? But if you can imagine it scales, you have like an Amazon scale, millions of providers. Yes. It gets a bigger problem. Yeah. So like proof of response is the system where you can prove that you were not able to fetch something. Like you go and say, hey, I want data from this API provider, and they promise that they will give it to me. Right, and you go through the system and you have a proof that they did not respond. Right, then you can go to blockchain and say, those embeddings are not good anymore because the provider was offline.
Yes. Yeah, that makes a lot of sense. Actually, it can be extended to like tool calling for API for agents, because you're creating like this API layer for all the agents. Then it's
that's the original idea, right? That if you have a lot of agents that promise to do something, if they are offline and you depend on them, that's a problem, right? It's sort of like a very simple example would be, you use some weather service to get weather, and the weather service is down, right? Your service is also down, right? But obviously, like the way agentic future is envisioned, that you have like millions of those agents, right? And you build, and each of them it's like a tree, of dependencies, or like a graph of dependencies. So you really want to know which of them are offline, and have some guarantees around it. Yeah. So what is I guess what's the timeline? When do you guys envision having the global knowledge base, or like early version of it?
Yes. So currently, I think how it works is that we're actively working with different protocols to like adopt our system. And then once we have enough agent on board and then providing this node, then we can gradually spawn like more like from like a protocol to protocol. So we can have a near protocol with some other protocol, all having their agent using our system. And then as more adoption comes, then this global protocol can gradually manifest.
Yeah. So like, is it going to be like happening this year, or like what do you think of the timeline before I can go there and say, hey guys, I want to fine tune my model on a bunch of I don't know 7 math problems?
Yeah, I think the technical side is not the roadblock now. It's more currently like how we work with different protocols and getting them to adopt our system. And as we get more and more like users adoption, then this idea can be manifested. So the roadblock is really on the adoption speed. Yeah. So that's kind of why we're actively providing ourselves for different AI agent frameworks. So whenever people use this or protocol, then it can be extrapolated to other things later. Yeah.
Sounds great. Okay, we
Thank you
are
so much.
almost out of time. Thanks a lot for coming, Felix, and telling us about XTrace.
Yeah, thank you so much.
Yeah. Okay, and see you everybody at the next episode of Office Hours.
Thank you, Alex.